Looking at this series, I see a fixed numerator, and in the denominator I'm going to express that as an exponent. That's n to the 3/4, and I know that that is a divergent p-series. If I tried to set that up with an inequality with the denominator that I have, this would be less than n to the 3/4 plus 2. And if we flip those over, I would have this one greater than this one. Now that's going the wrong way because I know this diverges, and having this bigger than this doesn't tell me anything. To use the comparison test, I would want to know that the lower one diverged, and then I would know the upper one did, but this is backwards, and so I'm going to go for limit comparison. So I'm going to take the limit as n goes to infinity of 4 over n to the 3/4 plus 2, and I'm going to compare that to, and I'm going to do it with the 4. I could have just done it 1 over n to the 3/4, but I know that if a p-series diverges, then 4 times the p-series diverges as well, and so I decided to put the 4 in there so that when I flip this over, I have n to the 3/4 over 4, and I could cancel the 4's. And then in order to evaluate this limit, I'm going to multiply numerator and denominator by 1 over n to the 3/4. And so let's go down here to write down what we have. We have limit as n goes to infinity of 1 over 1 plus 2 over n to the 3/4. And as we let n go to infinity, this is going to go to 0, and so our limit is 1. And so we know by the limit comparison test, if our limit is positive and finite, which it is, then the series we're testing does the same thing as the comparison series. And this was a divergent p-series, and so the series we are testing also diverges by the limit comparison test.